Good morning, guys. Today we're going to take a look at page 7 of the Unit 5 Classwork Packet. In the last video, we talked about the Triangle Sum Theorem, which says that there are 180 degrees in a triangle, and the Exterior Angle Theorem, which says that the angle outside a triangle is equal to the sum of the two faraway angles. Now we're going to take a look at how this would look like on the EOC, where you would potentially be faced with an algebra-based problem. Take a look at the following example, which is question number 13. Let's first identify what type of problem this is. Because I have 1, 2, 3 angles, and I have them all inside the triangle, this is going to be a triangle sum theorem problem. In other words, add the 3 expressions and set them equal to 180. Let's take a look at how that would work, okay? So I'm going to have 4x minus 22 plus 10x minus 4 plus 1x, also known as x, plus 11. Okay, so I've got this long equation. Many of you guys would probably be tempted to combine like terms before I even wrote this equation. And if you can, all power to you. I'm not going to mark that wrong. I mean, how would I know, right? That being said, though, make sure you don't make mistakes, okay? Because they're very easy to do. 4x, 10x make 14x plus 1x, that makes 15x, okay? I lost 22 and I lost 4 more, so I lost 26, but then I gained back 11. So if I lost 26 and I gained back 11, that means I only lost 15. All right, watch the integers. That's a big pitfall that always trips at least a few people up. So then I add 15 to both sides using the addition property of equality. Divide both sides by 15. Let me actually do that division for you, okay? 15 goes into 195 once. All right, so it's 3 times. So x equals 13. Okay. Oh dear, looks like I cut out part of the work there. Sorry about that. Anyway, so x equals 13. And then, in order to find the rest of what they're looking for, all I'd have to do is use substitution. For example, let's say they wanted an angle P. All I do is I take the 13 and I plug it in right here. So 10 times 13 is 130. 130 minus 4 is 126. Over here, 13 plus 11 is 24 degrees. And over here, 13 times 4 is 52, and 52 minus 22 is 30. In other words, algebra-based problems are actually your best friend. Even though they may be a little bit tedious, which means kind of like time-consuming and a little bit boring and irritating, they're actually very predictable. The only geometry in this entire thing was this number right here, recognizing that there are 180 degrees in a triangle. Everything from there is simply a review of Algebra 1. If you need to, pause me for a moment so you can get this information down. Okay? Now, we're going to take a look at one additional example, which is number 14. Okay? Now, oh dear. We're going to take a look at number 14. Okay? All right. So number 14 is a little bit different in that, unlike the other one, it's not necessarily going to be a triangle sum theorem problem. Instead, it's going to be an exterior angle theorem problem. And we'll see in a second what I mean by that. Okay? Okay. Notice that in this particular example, which is example 14 on page 7, I do not have all 3 angles inside. Okay, so it's not just going to be triangle sum. However, I do have an angle outside, which is known as an exterior angle. The exterior angle theorem says that this angle right here is equal to the sum of these two. Let me say that again. The exterior angle equals the sum of these two. So all I have to do then is actually translate that into algebra. So the exterior angle, the 18x minus 15, equals these two added up. So 13x minus 11 plus 4x plus 1. In order to actually solve for x, obviously I need to combine like terms first, right? Notice how the x's are on the same side here, and so are these constants. So I'm going to first combine those like terms. 17x minus 10. And then I'm going to use inverse operations. In this case, I would say better to get the x's on the left because it's going to make no negatives. So I'm going to subtract 17x from both sides. So x minus 15 equals negative 10. How do I get rid of a minus 15? By adding 15 to both sides. And thus I get x equals 5. Okay, that was the hard part. Now for the substitution. Let's say they want us to find angle CAB. Okay, CAB. So that's this one right here. All I gotta do is take the 5 and plug in. So 13 times 5 is 65. 65 minus 11 is 54. Okay. Similarly, if I want to find angle ABC, so this one right here, I just plug in. 4 times 5 is 20. 20 plus 1 is 21. Over here, if I want to find angle ACB, oh no, hold on, I skipped one. Angle ACB would be this one right here, which you can find by simply subtracting these two from 180, or you could find this one first and then subtract from 180. So it doesn't really matter, okay? Long story short, let's do this one first. Let's do BCD. So if I plugged in 5, I'm going to get 90 minus 15, which is 75, okay? And these two are a linear pair, so 180 minus 75 would give me 105 degrees for this angle right here, okay? Angle ACB. And of course, if I wanted to, I could actually check this, do these three angles inside add to 180, 75 plus 105, yes they do. Is this angle outside equal to the sum of these two far away? Yes it is, so we're good. The biggest piece of advice I can give you with these triangle problems, step 1, identify the problem. Is it triangle sum or is it exterior angle? Step 2, set up an equation and solve for x.